Right, this will be the first of 2 videos in which I'm going to be wrapping up Chapter 3, and this last part of the unit is focused on a few specific kinds of word problems, mostly focused around the concept of optimization. So if that word doesn't mean anything to you, optimizing something means finding the best possible result, the optimal solution. So we're going to see a couple of different contexts. This video is going to cover one kind, and then there will be a separate video that covers a different kind. So let's get our problem set up. We've got a farmer building a fence around some sort of field. And she's going to have enough wood to build a certain length of fence. And so all of these first sorts of questions are going to have a similar setup where you're working with rectangles and fields and fences and trying to maximize your area. So that's what we're going to be trying to optimize. So in our case, we've got enough lumber to build 200 meters of fence. And we want the biggest possible field because we're trying to, maximize the use of our fence. And so our question is, well, how big should the field be? What dimensions should we use to fit this question? So there's our setup. And so again, like I said, we want to maximize the area. And so that third word there, that maximize, that's super crucial. Maximizing is getting the biggest possible value. In other cases, maybe we're going to want to minimize something and get the smallest possible value. But in this case, we're maximizing. So this is a rectangle. Since we're thinking in terms of area, we're going to be looking at width and length. And so we've got a few things to keep in mind. Remember, the area of a rectangle is just the length times the width. And that's going to be just a standard equation that we'll use for all of these sorts of questions. The other neat thing we need to keep in mind is that we've got 200 meters worth of fencing material. That 200 meters doesn't correspond to the area, but rather it corresponds to the fence, which in this question you can think of as basically being the perimeter. It's the outside of the rectangle. So these lines here, these are our fences. And so if we're looking at that, we've got 2 of our lengths and 2 of our widths. But we also know how much that's going to be. It's 200. So instead of thinking in terms of perimeter, we can just say, well, 2 lengths plus 2 widths has to add up to 200 meters. So these 2 equations, this area equation and this equation with the lengths and the widths, these are going to be what we're going to do this equation with, or this question with, rather. So here's the general process. Step 1 was really just to write those equations. Step 2, we're going to take that second equation there, that 2L plus 2W equals 200, and we need to solve for one of the variables. It can be L or W, it doesn't really matter. Sometimes one might be a little bit easier than the other, depending on how the question is set up. So it'll be up to you to decide based off of what you're dealing with. But here, they both have a coefficient of 2, so it really makes no difference. So I'm going to solve for, let's say, the width. So I'm going to subtract 2L on both sides. Which gets me 2W equals negative 2L and 200. And then I just need to divide by 2. Remember to divide all your terms by 2. So I've got the width equals negative L plus 100, which doesn't seem like it's really accomplished much. It's just a different equation. But what we're going to do with this now is combine a couple of our equations together. So if you remember the systems of equations chapter that you probably would have done in grade 10, we can solve situations where we have multiple equations in a few different ways. You would have learned probably graphing, substitution, and elimination. In this case, graphing and elimination aren't going to be super helpful, so what we're going to do instead is we are going to solve by substituting. So we are going to substitute this equation that we've just gotten into the area formula that we set up at the start. So our area, remember, was length times width, but we just figured that our width can be written as negative L plus 100. So that is going to go in for W. So we're going to replace that W, substitute it out, and then see what we get. So we've got L times negative L plus 100. Right, so moving forward with this, we can distribute to get rid of that bracket, which will give us A equals negative L squared plus 100L. And so if you look at that, you'll notice, hey, we've got a quadratic. We've got an L squared. If we stop to think about this for a second, because that L squared has a negative at the front, it's got a negative coefficient, we know that if we were to graph it, it would be facing down. Now remember, the whole point of the question was to find the optimal solution. We wanted to maximize the area. Well, if we think of this graph, our maximum value is going to be at the vertex, which means, well, we need to figure out where the vertex is. And so if you think back, if we're in standard form like we are right now, to get the vertex, we need to complete the square. So that's our next step. And so that's just the same completing the square that we've done previously. If you don't know how to complete the square, you have come to this video too early and you should backtrack to a previous video. So our area, again, is negative L squared plus 100L. We're going to throw some brackets around those. So we don't even have a third term here, but we're putting around the first two terms. Remember, we need to take out the A value. In this case, that's just the negative, which leaves us L squared minus 100L. We divide by 2 and squared, so half of 100 is 50. 50 squared is 2,500. And we are going to add and subtract that in our brackets. We move that negative term out, and remember, when you do that, you have to multiply it with the A value, which in this case is just a negative 1. So we've got L squared minus 100L plus 2,500, and then plus 2,500 again. And then finishing everything off, we can factor that bracket and get negative L minus 50 squared plus 2,500. Again, remember, to get the 50, it's just 100 divided by 2. So, perfect. This gets us our vertex form. The question is, well, what does the vertex mean in this context? So if we think a little bit more carefully about what we've got, our p-value, which in this case is 50, would typically correspond to an x, right? And then our q value would typically correspond to a y. That's just usually how points work, right? If we're thinking of 50 and 2,500 as our p and our q, that's usually an x and a y. But if you look at this equation, we don't have x and we don't have y. What we've got instead are L and A, right? So this is what we've got instead of x, and that's what we've got instead of y. And so our 50 isn't an x value, it's a length value. That's the length that's going to get us the best possible area. And that y, well, it's actually the area. It's 2,500 meters squared. It's not the width. That's a common mistake. Don't get those confused. So to finish things off, we do actually have to figure out what the width is, which is thankfully pretty easy. If you look back up in your notes or in this video, we had this equation here that we made for W. W was negative L plus 100. And so we can just take advantage of that and figure out what our W was. So W is negative L plus 100, which in this case is negative 50 plus 100, which is just negative 50, or sorry, positive 50. And so there we go. We've got a length, we've got a width, we've got everything we need. Sometimes these questions might ask you for area, sometimes they might ask for dimensions, or sometimes they'll ask for both. The one thing to keep in mind here is this is just for this specific setup. So we ended up with the length and the width being the same. That is not always going to be the case. That only happens because we had a very basic plain rectangle. If you get anything more complicated, that's not going to happen. So trying out a second example, something similar but a little bit harder. So it's going to be a more complex field, and this time we're going to have 600 meters worth of fencing. So I'll draw you the field so you can get a sense of what we're looking at here. Still going to be a rectangle, right? That's always going to be the case for these. But now to maybe separate out some different kinds of animals or some different kinds of plants, our farmer is also going to divide up the field into parts. So this is what our field looks like now. It's got 3 different sections to it. So if you're feeling confident, feel free to pause this video now, go ahead and try the question on your own, and then come back to it later once you've gotten a handle on things. If you're totally lost and you don't know what's going on, stick around, I'll work through it, and we'll see how it turns out. All right, so to do this next one, the same process is going to apply as the first question, but things are going to be a little bit more complicated because we've got more lines. So we can still think of us as having 2 widths. Instead of thinking of it as being 3 pieces down here at the bottom, just think of one full side going all the way across. So we've got 2 of those. When it comes to our lengths, though, we have 4 lengths going across our field. So our setup is now going to change slightly. We've still got our area is our length times our width, but now instead of 2 lengths and 2 widths, it's 4 lengths and 2 widths. And now we're going to equal 600 because we've got 600 meters worth of stuff. You could absolutely say this is 1, 2, 3, 4, 5, 6 pieces, but that's going to make the solving process a little bit harder because we're going to be more likely to get fractions that way. So I always find it's easier to keep the numbers as small as possible. The other thing to keep in mind is if we're trying to solve this equation here, this 4 lengths and 2 widths, and we want to solve that for one of our variables, now it actually does matter which one we pick. If you're going to solve for L, you're going to have to divide by 4. If you're going to solve for W, you're going to have to divide by 2. And if you divide by 4 here, you're going to get fractions when you do 2 divided by 4. So it's better in this case to solve for width instead of length. So what I'm going to do is I'm going to subtract 4L on both sides, which is going to get me 2W equals negative 4L plus 600. And then to get rid of that 2, I just need to divide both sides by 2. And so I end up with W equals negative 2L plus 300. The rest of this is all pretty much the same as it was for the first one. So we go into our area formula. We're going to substitute out, in this case, the W for that equation that we just found. So it's going to be pretty much the same as last time. Area is length times negative 2L plus 300. If you distribute that out, you get negative 2L squared plus 300L. And now we complete the square. So I'm going to go through this pretty quickly because at this point you hopefully have a pretty good handle on how to do this. So we take out the negative 2, remembering to take it out from both terms. We divide by 2 and square and add and subtract. So that's going to be 75 squared, which is 5625. And then we take out the negative term, remembering, of course, to multiply it by our negative 2. So when we do that, we get 11,250. And so factoring it and putting it all together, we end up with our function as negative 2 L minus 75 squared plus 11,250. So you look at your p-value, right? You look in the brackets, that gives you your length. Sometimes it'll be width. Again, it just depends on which variable you solved for way back at the beginning. So from this, we get that our length is 75 meters. We can tell that our area is 11,250, although we don't actually really care about that in this question. It doesn't ask us for it. And now we want our width. So we go back to that equation that we so helpfully made up here and say our width was negative 2L plus 300. So if we take this 75 that we just found and plug it in for L there, our width is negative 2 times 75 plus 300, which is going to be negative 150 plus 300, which is just 150. And so there we go. We've got our length and we've got our width. There is a different way that you can get the width if you're interested. So we can also say that the area, remember, is length times width, and we know what the area is. It's just this. So it's the 11,250. So same idea, we're going to plug 75 in for the length. And now, instead of having to do all that stuff, we can also just divide both sides by 75, and that'll get us to the same spot. We'll still end up with our width being 150 meters. And so there you go. That is the basis of the optimizing questions when it comes to area. Again, sometimes you might end up with harder or simpler questions depending on what the shape of the fence looks like, but the gist is the same of setting up the perimeters, plugging stuff in, figuring out what your area formula is, completing the square, and then reading stuff off of that. So now that you've watched this, go ahead and flip over to the next optimization question, which will be looking at profits.